Really nice to see familiar faces and familiar names joining us again. So thanks for being here. Roy and I are actually really glad to welcome Yohei. He's here with us today to chat and demo really cool projects that he's built. And we're going to take a closer look today at knowledge graphs. This is actually the fifth installment that we're doing in the series, Graph and RAG. And before we're going to go into it, just a bit of an introduction. FalkorDB is an open source graph database management system designed to manage connected data in complex relationships. By representing data as interconnected nodes and edges, the system enables really efficient storage and super fast retrieval. There's a Q&A in the end, so you can feel free to send your questions in the chat box below. We're going to collect them. Those that we can get to, definitely we'll get back to you over email or Discord. But without further ado, let's kick things off. And we're going to go ahead and share our screen. Not too many slides, a lot of really hands-on stuff. So we're in for something really interesting, in my opinion. Roy, do you want to share or do you want me to?
No, go ahead. You can share the screen. I think we're kicking things off with one of Yoi's demos, but
yeah. I mean, we could show the title slide or we can just dive into the demo.
Yeah, let's go right ahead. Actually, the only
let's do it.
I want to show is VCPedia, so that's actually the first project we want to show. So let's go right ahead.
Yeah, this is a project from a few weeks ago. The history is that I spend a lot of time on Twitter and X. That's where I do a lot of learning. I learn a lot about AI trends. So I thought I would try building a tool to capture AI trends on Twitter using the Twitter API. When I was running that experiment, I noticed it was capturing funding rounds. And as a VC, knowing up-to-date information on funding rounds, especially at the pre-seed stage, which you don't find on a lot of other databases, is important. I'm a pre-seed investor, and I noticed that a lot of pre-seed funding rounds were being announced on Twitter. So I had this idea on a Friday, vibe coded it with Replit, and I'm going to go ahead and share it with you. It looks like this. VCPedia, the number of startups, investors, rounds, and recent funding. This is what's been captured this week. Here's some trending startups based on social signals. It does capture some noise. I'll touch on that. Funding rounds by type, funding trends, notable AI startups. I set up a section for that because that's something I'm personally curious about. And then you can see kind of the recently funded, added funding rounds. Now, if you click into one of the startups, for example, Pistachio, this is the most recently captured funding round. I click through to it. It will give me information about, let's give it a second. It's not optimized for speed. It captures information, company info, business info, industry tags, business model, similar startups, which is just a vector search against other startups in the system. Funding rounds it's captured on Twitter. Again, this doesn't go historical. It's only capturing funding rounds from when I started this. Investors that it'll extract and create a page for, and then you can see the actual tweets where it captured the funding round. When you go, or I guess if you go back here and you look at the ones that are trending, and let's say if I were to click through those will be those are actually using social signals. So if we click through to the tweet, you'll see that those tweets are getting a lot of engagement. So the way this is set up, actually, I did a little. Yes, if you click through to here, you see this, Twitter announcement. So this one said it was trending. So if I click through, I'm likely going to see that this one has a decent amount of engagement. So I'm not just capturing funding rounds, but I'm also able to identify funding rounds that captured a lot of people's attention. This is really helpful for me. I threw the code into an LLM to describe how it's working. Is that I have the Twitter API, a couple search queries set up that run on a certain frequency. It runs through the Twitter client. I enhance the queries a little bit. I don't want retweets. I want to make sure they're verified just to remove some noise. I deduplicate tweets because I don't want to analyze the same tweet twice. And then once we have a tweet object, then we will go through funding detection. Is there a funding round? If there is, let's extract the information that it has, which is information about the startup, the funding round, the founders, and the investors. There's an entity resolution layer here where for all of these, it will go through a deduplication to see if it already if any of these exist, such as the startup, the founders, the investors. And then once it's deduplicated, then there's a data enrichment layer. You see here, there's like SERP, EXA, OpenAI. I've tried a couple of different enrichments, but they'll enrich the data, and then this all gets added into the relationship tables. So that's kind of VCPedia as a quick intro. I know we were going to talk about this a little bit, but
This is very, very cool. So I would say with that background, I think, Roy, now would be a good time to sort of go into a little bit about what's happening in the background so that when we're further talking about this, we can refer back and people understand sort of what we're referring to. So I'm going to go ahead and maybe, actually, Yohei, I'm seeing you have the slides open on your end. Maybe you can jump.
I did open them up.
Perfect, yeah. So essentially what we have was VCPedia, and then we wanted to go a little bit into the fundamentals of a knowledge graph, of what's happening behind the scenes, which is slide number 3.
Cool.
Right. So thank you, Yohei and Dan. In a kind of a brief, we have just a few slides to give the audience some information about what's empowering all of those new applications that are coming into the market and are using LLMs and AI to drive both insights, but also really help with capturing the data, analyzing it, and then prepare it for storage. And so one of the fundamental data structures that are being used these days is a knowledge graph. And a knowledge graph is not a new idea. It's been around for at least 10 years now. But now with the explosion of Gen AI, it got the spotlight back on it. And so with a knowledge graph, basically, you have graph entities. Those are either nodes, which represent some type of an entity in your domain. And then you can connect those entities with edges to capture the different relationships between them. Nodes and edges can be labeled. So you can have a label representing a person, and you can have an edge capturing some type of an interaction, for example, between two different persons. Also, you can enrich the data with an attribute set. And the attribute set is basically, you can think of it as a key value storage attached to a graph entity. So for example, a person can have an attribute set containing name, maybe a zip code, a birth date, whatever information you need to make the entity usable for your use case. And obviously, there's a variety of different data types that can be used, such as numerical values, strings, array, vectors, and more. If we can move on to the next slide, please. Thanks. So here's an example of a more concrete knowledge graph in which the domain here is art, I would assume. The entities that are being captured are artists, such as Leonardo da Vinci, the paintings, and museums. And so there is an interaction between those different entities. So for example, an artist had drawn a picture, and the picture might be presented at a museum. I think there's a lot of value representing your data in such a way. First, it's very visual, so you can look at it and you can reason about it relatively easily. Second, the fact that most knowledge graphs, or the essence of knowledge graph, is schemaless, this really helps or gives you the flexibility that you might need when representing your data. And lastly, there's no restriction on the number of different entities and the number of different relations that you can have in your graph. So you can actually go quite wild with it. With that said, if we can move on to the last slide, constructing a knowledge graph can be challenging. It's not like the one of the other solutions that we see these days with vector databases, where the ingestion procedure is really straightforward, but extremely limited in terms of your reasoning capabilities. And so these are our suggestions whenever it comes to knowledge graph construction. First, make sure that the domain that you're trying to capture is well defined, meaning that you try to limit yourself in a kind of a focused scope. So once you have defined or know what type of data you want to capture, with every other system, there's this phase of data collection and data cleaning. And that could go to an extent, or you can just work with the data that you have without performing any cleaning. Really depends on how are you ingesting the data. So after data had been collected and cleaned, what we suggest that really helps LLMs to interact with your data is to define the semantics. And usually that means defining a clear ontology. And I'm sorry for using this terminology. I would try to keep it simple. Basically, an ontology is a schema of your data, something that you might be familiar with the relational model. It's basically a schema for your graph, although I said just a few minutes ago that knowledge graph are schemaless. There is value in following a strict schema later on in the retrieval phases of your application. And so this is where you're saying, oh, my graph contains a person, and a person is associated with these attributes. A person might have edges coming into it or going out of it of these specific types. And maybe some of these relationship types are also associated with some attributes. So this is the ontology defining my graph. Once you have the ontology in your data, it's time to ingest, meaning pushing the data into your graph. And lastly, doing some validations, making sure that the knowledge that is being captured is really valuable. And for example, if you're using an LLM to query your knowledge graph, that the accuracy of the results for different questions that you're asking is satisfied. You can move on to the next slide.
Cool. Actually, before we jump into FractalKG, I think just applying it to VCPedia, obviously in the case of VCPedia, the domain is startups funding, right? Data collection is happening on Twitter. In this case, there is a very clear ontology, right? It's the funding round relationship with people relationship with startups, and I think for me at least, I found that using structured output with LLMs is a great way to get the structured data out of your unstructured data. You can essentially use the ontology that he was describing, and what I essentially do is turn that ontology into the structured output format to get the data. And then the validation step, I think, is the one where I think mine could use a little more work. But we were talking about this the other day. My strategy has mostly been to every time you add a node or relationship, look for similar nodes, and then most recently I've been feeding those similar nodes and new node into an LLM and having the LLM decide. But I think you can go even further and do kind of deterministic validation. If it's the exact same domain, then they're the same entity and so on. So yeah, that's basically exactly how VCPedia was built.
Right.
I know the next one we were going to talk about is FractalKG. I think before I jump in, I was going to quickly just share that I've been trying to, I think I started exploring knowledge graphs initially right after I built Baby AGI. I had a couple people reach out saying you should look at knowledge graphs, you'll like it. After enough time, I thought, okay, I'll take a look. And then immediately clicked. It just felt like a very intuitive and natural way for AI to kind of traverse data, right? If you think about VCPedia, if I have a startup, right, being able to just like for the AI to be able to pull just all the edges related to that startup is a fantastic way to pull all the context. If you were to do that with relational tables, you essentially have to find the relationship mapping between the startup and each table that exists. You have to find the relationship between the startup people table, search through the people table for all people that match that startup. Then you go to the startup funding round relationship mapping and then go through all the funding rounds and then grab all the funding rounds that match the startup. And then you go through all the investors that map versus just being able to pull edges. To me, intuitively made more sense. So I've been playing around. I've tried a couple of approaches on what it's now called GraphRag. The first one I tried looked like this. It was called MindGraph. And the key really here was this kind of add multiple conditional. The big thing about building these massive knowledge graph is really in the deduping. So this is where I had the add multiple edges and rows conditionally. There's a conditional entity addition, which was the kind of dedupe and add. And that was a while ago. It was pretty beefy code. I then tried a more recent one earlier this year. This is not yet FractalKG I called it Graphista. I was really trying to simplify the code. What I did was I had a smart node processor and retrieval tool, and it was an LLM loop with a whole bunch of graph query tools. And I thought the idea was if I gave the LLM enough prompts, it would figure out how to dedupe correctly. It somewhat worked, but realistically, I found that I think the earlier version was better. The deterministic ended up working better. So the most recent approach I did was FractalKG, which has an added element of trying to self-organize itself into kind of a fractal-based graph, which I'll kind of explain through a quick demo in a second. What you're seeing here is a knowledge graph of a whole bunch of articles pulled in from Wikipedia. It's automatically extracting entities, relationships, and mapping them into a graph. I think somewhere I had a quick explanation of how this version works. I asked trusty Claude to work through it. In this case, there's the raw document text that goes in. It first identifies entities, and then it goes through an entity resolution step where for each entity, it looks to see if there's existing entities. So in some cases, it might say there's an existing node. In some cases, it might say, we need a new node. And then once we do that, there's an extract fact step. Facts in this case, and in the case of FractalKG, every fact is a triplet, which is a entity relationship entity. Like Einstein developed theory of relativity. And then those are then mapped into, attach the facts to the entities, create the graph edges based on the relationships, batch, deduplicate, and kind of self-organize. So let's do a little live demo. I think this was, I think I did. So what one of the things I noticed when I was trying to do graph rag, right, kind of retrieve context, is that if I just if the graph got too big, pulling in all the edges kind of went over the context limit. So what I wanted to figure out was, can I build a system that can reflect on itself and self-organize? Maybe if one node has too many children, it can then cluster the children, create kind of subcategories between them so that there's no single node has too many edges. And so that was inspired kind of like the way we dream, right? So there's the kind of go through each node and self-organize. But to show you kind of how that happens live, I think the test I did was Yohei loves, let's say AI, John loves tech. Now, what you would expect, at least from my previous one, was that it would just generate a Yohei to AI relationship and a John to tech relationship. But in this case, because it's trying to self-organize and understand and infer a relationship between nodes as it's creating them, it should build a relationship between AI and technology automatically when it displays. I think it should display in Second, there it goes. Okay, in this case it did not. But let's try the, was it self-organize? Or, I guess it didn't work in this case. Earlier when I did this test, it did a, yeah, let's just jump to that earlier test I did. Earlier when I did the same query, it did this. And then if I go in and say, what is John's relationship with AI, it says there's no direct relationship between John and AI based on given facts. While AI is a subset of technology, the fact does not explicitly state that John loves AI, only technology in general. So it does remember that John loves technology, but it does see that John, technology has a relationship with AI, if that makes sense.
I think it does, I mean, especially in the context of people that are trying to build an agent that is supposed to have a memory and hold that memory and provide answers that actually bear some context. So I think what you're showing here is very cool.
Yeah, and most of the kind of ingestion and retrieval is in a single file that's about 1,000 lines of code, and I think we're working on getting it ready to open source too. So if you want to play around at least with this approach, we'll be able to share it soon.
That's very cool. Yeah, definitely. I mean, once that's up there, we're going to put it on Discord and disseminate it to everybody that attended so they can play with it as well. But I think it's really cool. It's what we had in mind, I think, when we started building this.
Yeah. I know we were talking about like why graphs a little bit the other day.
Yeah.
And I'm not someone who studied graphs, but I think in understand like most of business, right, and the way we work is actually just a lot of relationships, right? There's even when I look at the way I work, there's emails, there's notes, there's people, there's relationship between people, businesses, and so I think graphs do an incredible job of capturing the way in which the real world works. One of the opportunities I'm excited about is that with graphs, there's, and again, I'm pretty still shallow on this, but there's a lot of kind of algorithms that help you better understand kind of the relationship between graphs and the network at large. And I think as I think about, especially for me, right, in the startup ecosystem, and I think for other people, you'll find similar things, is that I believe that if I can create a strong graph that captures the innovation ecosystem, right? What are the industries? What are the technologies? Who are the investors? Who are the customers? Then eventually we'll be able to start identifying pockets of underserved innovation, right? Opportunities where we're seeing a lot of where we should see a lot of activity, but maybe aren't seeing as much funding happening. And then if I'm able to start identifying those, I mean, for myself, I can start looking at those and investing in those. But for founders, they can start, looking for, there's probably innovations that happen in certain industries that should obviously apply in another. It just hasn't happened yet. And being able to identify those automatically, I think graphs are really well suited for that. So I think it's beyond just capturing the existing relationships and the businesses, but also being able to infer opportunities within those graphs. And I think, at least from my understanding, is that the biggest challenge with knowledge graphs, at least prior to LLMs, was building and maintaining these clean knowledge graphs. It just took too much manpower. And I think with the reasoning capabilities, the data structuring capabilities of LLMs, I think we're finally at a place where we are able to build and maintain large knowledge graphs. And then if we can do that, we can infer insight from them. And I think we're still early, as I talk to people, but I think it's the right time to figure it out. And I think if you can figure it out, you can definitely have a leg up in helping people organize data and gain insight from it. So that's been my motivation. That's my hypothesis as I dug into and play with knowledge graphs. And of course, that exploration led me to working with you guys at Falkor. So that's been my experience.
I'm really happy you brought that up. I know we talked about it a few days ago, and I was hoping that the insights you shared back then would be ones that you would share with the audience today too, because I think we feel the same way, and we see it pop up on a lot of the conversations that we're having. I think people are reaching the same conclusions. I'm just looking at the time, and I know before we even started the session, we had gotten questions people wanted answered, and there's a few that have gathered in the chat. So would you guys mind if we, because we didn't want this to be slide heavy, right? There wasn't like a presentation in mind. It was more like a demo showing what's going on behind the scenes and sort of the rationale behind things. So I think it would make sense to keep the discussion going instead of showing more slides.
Yeah.
So the first question is a bit long. It's quite cool. So I'm going to read it out loud. And if you need me to repeat a part of it, please let me know. So it's from, I can't really tell the name of who asked it. So we're just going to answer it live. And later on, when we send the email recapping this, if you've asked this question, you're probably going to recognize the answer. So the question goes, what rule or heuristic should one use to determine whether some information should be a node versus an attribute of a node? The example given here is an individual might be a node in the graph and their name would likely be an attribute, but what about their country? The person also says, I can see a case for that being either a node or an attribute. Perhaps this is where upfront ontology definition comes into play. Roy, I think you touched a little bit on this, but
Yeah, it's a good question, and I think it's a question that a lot are get to ask themselves whenever they're trying to model their data. And so there isn't a clear and correct answer. For some, treating a piece of information as an attribute might be the right way to go. For others, it might make sense to treat this piece of information as a node. My general way of thinking about this is if you're trying to visual your data as a graph, whatever comes to your mind naturally, that's the data model that you probably want to start experimenting with. Also, if the data point which we're thinking of seems trivial, like at the beginning of the question, then there's not much to think about. But let's try and think about the country piece of information. So a person might be a resident or have a certain nationality. And so you might represent the country as an attribute for every person in your graph. And so, for example, if you're just maintaining the string of that person, then one thing that comes to mind is the memory consumption. If you have millions of different persons, then the small set of strings representing countries would duplicate itself over and over and over again. So memory might come to mind. And actually, we've addressed this in our latest release. We have this feature called string interning, where you can specify, hey, this is a string which comes pretty often. Don't duplicate it. Use unique value of it, and everything is being shared. So this is one thing to take into consideration. Another thing is the way in which you're going about traversing or searching for knowledge. So you need to think about the different type of questions that your system is intended to answer. So for example, if you're want to do traversal from a country outward, it would make sense to represent a country as a node. But if you are more focused on person, you're trying to locate a person via its unique identifier or social security number, and you just want to see, for example, in which state that person lives, then it might make sense to have this as an attribute. You can still go with a node, but then you would have to traverse from that person to a country node and retrieve the name of the country. So kind of summarizing things up, go with the most natural way of thinking about the data as a graph and see if the data model that you have chosen fits the different type of queries and questions that you're intending to answer.
Yeah, I would say the same thing. Like the last thing you said, especially for me, right? Again, I'm not as deep on the understanding how to optimize the queries piece, but I think starting from the queries is important, right? If you're going to constantly filter your data by country, I would guess that it would be intuitive to turn that into a node. But if it's something you just like want to see when you visit their page as a side note, then you might not need to add that as a node. Is kind of how I would think about it. And I think, again, if you have a lot of data, you do have to worry about the costs. So I'll speak as kind of a more of a prototype or getting going stage. Initially, I think keeping it simple is good, and you can kind of test around with small pieces of data. And then if you feel like it's helpful, I mean, if you have the location data as an attribute, it should be pretty easy to convert that location data and map it to a location node. Again, if you have millions of data, you might want to do it up front versus doing it later. But at least in the prototyping stage, you can easily add that after the fact.
Yeah, maybe let me just add a few things to that. Graphs are dynamic, and so if you are going, you have experimented with one data model, you can quite easily transition to another. That's one thing. Another maybe thing to keep in mind, following on this country example, is are you expecting the country to be interacting with other pieces of information? Like maybe now you only have the relation between a person and a country, but maybe in the near future, you're seeing country being referenced or interacting with different entities. And if that's the case, I would lean toward representing it as a node just because the ability of capturing those different interactions.
Excellent, guys. Another question we have is from MJ. He's asking, when working with documents, what detail are we saving in FalkorDB? Would you store sentences, paragraphs, or summaries? If only storing summaries, are you also storing entire documents in a separate database?
Right. This is classic RAG question, I would say. And once again, there's no right answer. I think all options are viable, and it really depends on the type of questions and the level of accuracy that you are aiming for. We've seen all different options. Some people are actually analyzing the documents, for example, with LLMs, creating embeddings, extracting sentences, creating summaries, and all of the relationship between the different components, paragraphs, sentences, summaries, entire documents. These can be represented as nodes in a graph. So, for example, whenever you're trying to answer a question via the classical RAG approach where you are creating embeddings for the question, and then you're doing semantic search to get to maybe the summary or maybe to get to the relevant paragraphs, then you can utilize the graph in order to get a hold of the original document. And maybe there's a hierarchy of documents saying, oh, this document is a page from a broader a corpus, or oh, this is a Wikipedia article that is linked to other Wikipedia's pages. Maybe I want to extend my context and get some extra data in by traversing the graph. And so there's no clear answer. I think you should experiment with it. But the benefits of storing this information in the graph allows you to retrieve additional context, which usually it's relevant to extending the context with um, information that would help your LLM to generate the correct answer.
Yeah, this feels like more of a FalkorDB specific one, but I think that like again going back to like what is the query? How would you want to display it? I think is what comes to mind. In a lot of cases, when you do RAG, you might want to provide the source snippet of the fact. You know, whether you do or don't should affect your decision around whether to keep the document, right? If it's a massive PDF that you had to chunk to analyze and store, maybe it makes sense to store the chunks because if you want to store, if you want, if you find the fact and you want to grab the snippet, you don't want to have to go through and search through the entire PDF for that snippet again. That seems just really inefficient. You would almost rather store the snippet with the facts so that you can quickly pull the snippet instead of searching for it each time. So again, kind of depends on what's the information you want to display, how do you display it, what is the flow to get that information in front of the user, and I think that comes through testing not just the graph itself, but also the UI and making sure it's kind of cohesive and makes sense.
The next one, guys, comes from Brett. He says, if I understand correctly from the earlier slides, despite the knowledge graph system being schemaless, developing an ontology is useful in an actual exercise to help nudge the development and maintenance of the model that the system develops. Are there any useful mechanisms for enforcing that ontology within the knowledge graph system automatically?
There are some mechanisms, yes, but the overall model that we're following is known as the property graph model, which in its core is schemaless. The way in which you can start enforcing the schema, the feature that FalkorDB offers, is with constraints. Currently, we have two different constraints. One is unique constraints, and the other one is exists constraints. The unique constraint makes sure that an attribute is unique throughout an entire entity type. So for example, social security number should be unique for every person. In addition, the exist constraint makes sure that every entity of a certain type, let's say a country, must have a population attribute. It doesn't have to be unique, but it must exist. That's what we currently offer. It would not enforce, for example, introducing new labels or new relationship types that are not part of the ontology. It would not enforce the type of edges coming in or going out from a certain node type. So for example, if your ontology says that there should not be an edge of type driven to, that would not be enforced. And I think that over time, the plan is to introduce schema enforcement mechanisms and features into FalkorDB, but at the moment, the intention is for, or the responsibility for the user to enforce the ontology to make sure that the underlying graph follows the ontology, and that could be done either via code that is being written by the user or by guiding an LLM to strictly follow the ontology whenever doing updates, deletions, or ingesting new data in.
I think there's it's not a question, but it's rather a comment on what Brett asked. And I think it ties in a little bit with something Yohei talked about when he presented FractalKG. So in response to Brett's question, we have Alec saying, based on my observation, the ontology schema behaves like prompt engineering technique with your LLM that you are using to classify the data you are processing, either as entities or edges? What do we think about that?
I mean, the ontology schema is something if you set ahead of time, right? I think the earlier point was it makes retrieval easier because you can more deterministically ask questions without worrying about having two similar edge types, right? Because you've already defined the edge types. And I think the original question was around whether you can enforce it in the KG, which it seems like it doesn't. I think, and I don't know if I'm answering the question, but you can enforce it up front. Using, for example, in my case, I use structured outputs. And so I ask the structured output when I'm extracting data to extract nodes or edges in a specific format. And if I want certain relationship types, that'll just be one of these structured output parameters, and I can stick an enum and give the specific types that I want. I don't know if I'm answering that question, but to some extent, I think you can use prompt engineering or structured output engineering techniques to enforce that ontology, at least in the data creation step before you throw it into the graph.
I'm gonna add to that. I think that ontology can be thought of as prompt engineering. I think that the main idea here is to restrict or make sure that the LLM is aware of what exactly is captured in your knowledge graph. So think about the situation in which you're telling your LLM, hey, you have access to a graph capturing driving information, and that's all the information that you're giving it, in addition to a question that says, find me all of the driving sessions that had top speed over 60 miles. And so there are some hints within the question for the LLM to try and guess which attributes, which nodes, and which relationships are within the knowledge graph. But it would have made more sense, and it would really help the LLM to get this information up front, knowing that there is a driving session entity, it has a top speed attribute, it is connected to roads. And so now the LLM is confined, and it is certain about what exactly is in the knowledge graph, and that would really boost the accuracy of the LLM when composing queries against the graph.
Excellent. I'm looking at some of those questions. Some have to do with Yohei's projects, and some speak more about the core product that Falkor essentially has developed. So just in the interest of time, I'm going to read them from top to bottom. And no worries, we're going to answer all of those questions and send the very detailed answers to all of them later on. But there's a question that came in: what graph embedding models are supported? And they specify node, edge, or graph embeddings.
Oh, that's easy. None. We do not have GNN's capabilities or graph embeddings. The only type of embeddings that we're supporting at the moment are vector embeddings, the ones in which you can generate with different LLMs or AI vendors. Once you have those vector embeddings, then you can utilize our semantic index to do vector searches. But I know that there's interest in GNNs to do both node label prediction, edge prediction, and subgraph classification. Unfortunately, that's not supported at the moment.
Yeah. There's a question that came in from Discord, and they're asking, should I use a knowledge graph per domain or a single knowledge graph containing all the domain data?
So this is a cool question. I think that it really depends on the use case. But let me say this. If you do see value in storing all of your information, which might span across multiple domains in a single graph, you can do that. And the nice thing about this is that you can have multiple ontologies all describing different portions of your graph. So you would have one ontology, for example, defining one domain which might be around driving sessions, but your graph expands further. It doesn't contain only driving sessions with roads and intersections. It might contain other information that is still related to that. Let's say cities and population and universities, whatever have you. But then you can still maintain two different ontologies, one which is focusing on the driving sessions, and the other one which focus on, let's say, population and employment. But those two all coexist within a single graph. It is the LLM and the ontology that is represented to it that would know how to filter or focus on the relevant pieces of information within this larger graph. The other option is, if you don't see value in connecting everything together, is another very cool feature of FalkorDB that allows you to maintain multiple graphs in a single database. And so similar to SQL, where you have multiple tables within a single database, here you can have multiple disjoint graphs all within a single database. So you can keep them separated, you can join them together, you can have one ontology per graph, or you can have multiple ontologies capturing data from sub graphs within a single one.
I'm glad you brought the multi-tenancy aspect of it. The next question is for Yohei. If VCPedia supported multiple languages, would you add a translation step or store the tweets in their original language?
I would probably store the tweets in the original language and simply translate the output of the site. But that's just my gut reaction. I don't really have a strong reason for it.
Yeah, I wish maybe the question elaborated a bit more, but yeah, that's actually what I had in mind that you would say. So we have another question from Discord that I think is actually very interesting. We touched on it early on, I think a little bit in the beginning, but maybe it's worth taking maybe a few minutes to talk about it as well. How does an ontology scale when my data updates?
Okay. So it really depends on the update. I mean, you can think for this particular question, you can think about two different types of updates. One updates that doesn't change the ontology, meaning that you're just adding a new city or a new university or a new person into your graph that doesn't change the ontology. It remains the same. The other type of update is if you are adding a new type of entity. So for example, maybe you're adding a truck to your driving session, which only had cars in it, but now there is a truck. And so we do not enforce alignment between the underlying graph and the ontology. This is something that the user needs to maintain, just like the way in which we're not enforcing schema. Whenever you're introducing a new type of entity, it is you should extend your ontology to capture that. So with this truck example, you should add a new entity to your ontology describing how does the truck looks like, meaning the attributes associated with it, and the different type of relationship that are interacting with this new truck entity.
Excellent. I want to, since we only have 10 minutes left, I think it would be worthy to take one more question. And then there was another question on Discord that I think sort of leads into what I want to say to sort of recap everything. So the question we got from Discord was, is there an automated way to build a knowledge graph, which is the topic for actually the next workshop we want to put together. So let me pause on that, and we're going to go into what we're going to do next time, which is a more of a hands-on workshop that talks specifically about that. But the other question that we got here on Zoom is, how can I improve the attribute extraction for each entity from my strict ontology schema for my knowledge graph? For example, I would get non-relevant context assigned to an entity or incomplete. I hypothesize my chunking is wrong, or I need to employ more natural language processing steps.
Again, it's hard to see. I feel like with graphs, it's hard to solve a problem without knowing the specifics because it is really kind of case by case in terms of like what data you're playing with. But the few things that pop to mind that's worked for me, again, in different cases is, I mean, K-shot is always helpful, right? Giving a couple of examples. If you're converting large documents and you need to chunk it, again, this is a simple example, but sometimes you need kind of higher level context of the document for each chunk, right? A simple example might be the book starts by using people names, but later on it uses he or she instead. And if you grab that paragraph and try to convert it, that he, like the name might not be matching. So you might need to have kind of higher level context that you feed into the chunk if you're chunking and then extracting. And then just I think a lot of I found that adding clear descriptions when you use structured output for each parameter, you can provide descriptions, you can provide kind of hard-coded rules on options, and using that kind of the structured output defining JSON and improving the prompt there, I found is also helpful. So those are just some techniques that popped in my mind.
Right. Yeah, I think that going structured can really help here. I don't know if this feature is still available, but back then, a few months ago, where I was constructing knowledge graph from unstructured data, OpenAI had this feature of defining functions. So you can define functions or tools for your LLM to use whenever instructed to, let's say, extract entities and relations from documents. And so what I did was to say, okay, I have, for example, 5 different types of entities. So I would create a function, create function for each one of those. And each function would get a set of arguments, attributes. Some of them were optionals, others were mandatory. You can specify the type. And now the LLM is equipped with this set of functions. And so it is the LLM responsibility to invoke the most relevant function whenever it encounters data that can be translated into an entity. And so the LLM knows, okay, for example, I'm seeing here some description of a city. Okay, do I have a create city function? Yes. Okay, which arguments do I need? Oh, the name is mandatory and it should be a string. And so now the LLM is very restricted and have certain rules to follow when invoking a function or creating an entity. So that really helped out. So that's another way that you can go about experimenting with detecting and creating entities from unstructured data.
Super good. I'm going to hijack the screen just for a little bit. Can everybody see me?
Yep.
Perfect. So first of all, thank you, Yohei, for taking the time. Thank you, Roy, for you are my trusty partner. We're doing this maybe for the fifth time. We're getting, I think, really good at this. And every time, I think the level of questions that we're getting, I'm really liking it. Every time I would say it's a healthy balance between challenge and just passion. Like it's what we do every day, and it's nice to share it with everybody. Speaking about the question we got on Discord on how to actually build a knowledge graph, this is exactly what we want to do next time we meet. I put up here on the screen a QR code, but you don't have to scan it right now if you don't have a phone. I'm definitely going to send you a link later. But this would be the topic of what we're doing the next time. We want to be able to show you how you construct a knowledge graph, how we go about this, the methodology that we use, and also the logic behind how we do what we do. That's happening in a little bit over a month, so that you definitely have time to sign up. And there's a few questions that I saw on the Q&A. Everything that we do here is recorded. It's going to be on Discord and on YouTube within the next 24 hours. So there's no worries if you've missed parts of it in the beginning. And we're going to, like we did last time, we sort of collate all the questions that were pulled here. We're going to answer them, and that's going to be something that exists on our blog so that you can revisit it later. And also, we tend to pick out the really good questions that we wanted to focus on and put that in an email as well. So nothing is lost there. There's no worries there. And we really, if you felt this was useful to what you're building right now, I think the next installment in July on how to actually build a knowledge graph is something you definitely want to check out. With that being said, I really appreciate you guys' time speaking with us today. I thought it was awesome. Every time we do one of these workshops and somebody shares their screen and actually shows a project that they've worked on and sort of explains the rationale behind it, that's the kind of content I want to consume. And I think that's the kind of content people are coming here for. So I would say there are a few people that I'm recognizing and have attended before, but for those who are new to this sort of format of what FalkorDB does, these tend to be the sort of conversations that we're having. They tend to be very technical and very hands-on. So we hope you appreciate it. Anything else we want to say, Yohei, Roy, before we go?
No, thanks for having me. It's always fun to nerd out on graphs.
100%. Yeah. These are really cool projects. I think when we were putting this together, I thought it was really cool. I really wanted you to share it with everyone.
Oh, thank
With that
you.
being I'm seeing more questions come in. There's no worries. We're gonna, like I said, pull all of them together and answer them. With that being said, please scan the QR code that you see here to join us on the next event. If you can, there's no worries. After this event is finished, I'm going to send the link. And with that being said, I want to thank you for being with us today, and we'll see you the next time.
Thank you.
Thanks, guys.
Thanks.